Hope tried to prove the abnormal behavior of the water. He did some experiment so that we may understand the abnormal behavior. What was that abnormal behavior? The abnormal behavior we have is, then when the water is heated from 0 to 4, it contracts, and when it is cooled from 4 to 0 degrees centigrade, it expands, and ice is lighter than water. So all these things Hope tried to prove with his experiment. We call it as a Hope's experiment. So this is the Hope's apparatus as available in the market, right? You can see a central cylinder in which the water is filled up. You have two openings, not exactly the openings, but a slot to insert the thermometers, right? They are not openings, otherwise the central water will flow out. These parts, right, these two openings have a cork fitted in them, just so that the thermometer can be inserted. In this middle trough we place a freezing mixture. Freezing mixture is generally ice plus salt. So central cylinder has water, the middle trough has the freezing mixture, and the two openings has a thermometer. So this is some illustrative representation of the Hope's apparatus. Let us start with the Hope's experiment. So as soon as we begin the experiment, we'll take down the observations. What will be our observations? Our observations will be the temperatures of the upper and the lower thermometers, right? After noting down those observations of upper and lower thermometer, we'll plot a graph. So final graph you will have something like this. So we'll take observations at every 5 seconds, right? Let us start with the experiment. Initially, we take water at 10 degrees centigrade. In all these regions, we have water at 10 degrees centigrade. As soon as we place the freezing mixture in the central trough, the water in the central region will start cooling. As soon as the water in the central region starts cooling, let's say from 10, it has cooled down to 8 degrees centigrade. What will happen? Cooling means contraction. Contraction means becoming heavier, and this heavy water will settle down. Normal behavior. The abnormal behavior is only between 0 to 4. So this heavy water settles down and this lighter water goes up. Eventually from 10, it will also attain 8 degrees centigrade. So after 5 seconds, we observe that the lower thermometer, right, it shows some 8 degrees centigrade. What about upper thermometer? The upper thermometer is still showing 10 degrees centigrade. After 5 seconds, the water in the central region is at 8 degree, the lower region is at 8 degree, but the water in the upper region is at 10 degree. What happens after next 5 seconds? Within next 5 seconds, let's say this water further cools up and attains 6 degree, right? Becoming cooler means contraction. Contraction means becoming heavier. This water will settle down. The water at 8 degree, which is comparatively lighter, will rise up. Because of the cooling mixture, it will eventually become 6 degrees centigrade. Let us plot this thing into the graph. In the next 5 seconds, right, let's say 10 seconds, we observe that the lower thermometer, its reading is 6 degrees centigrade. But when we observe upper thermometer, almost no change at all. Upper thermometer is showing no change at all. Next 5 seconds. So now we have, after 10 seconds, we have water at 6 degree in the middle region and water at 6 degree in the lower region, and upper water is almost at 10 degrees centigrade. So for first 5 seconds, or you may say for next 5 seconds, the lower cyclic currents are set up. So we can write down our observation as, right, due to freezing mixture, water in middle region becomes lighter, and settles down. Eventually we can say that lower cyclic current is set up. The water in the central region and the lower region keeps rotating. Let us see for how long the rotation takes place. So again, let's observe for the next 5 seconds. So after 15 seconds, let's say the water has attained 4 degrees centigrade, again a normal behavior. Cooling means contraction, and contraction means becoming heavier. The water will settle down. The lower water, which was at 6 degree, right, will rise up, eventually due to freezing mixture attain 4 degrees centigrade. So after 15 seconds we observe that the lower thermometer shows 4 degrees centigrade, whereas the upper thermometer, if you observe, its temperature has slightly come down, you may say 9 degrees centigrade. So upper water has now cooled to 9 degrees centigrade. The middle water is at now 4 degrees centigrade. Now some abnormal observations can be seen. So after 15 seconds, right, we have water in the middle region at 4 degrees centigrade. The lower thermometer is showing 4 degrees centigrade, and the upper thermometer, it shows 9 degrees centigrade. Now once again, because of this freezing mixture, the water in the central region will cool to 2 degrees centigrade, right? What will happen now? We know that there is some abnormal behavior between 0 to 4. So when it is cooled from 4 to 2, rather than contracting, it will expand. The water will expand, it will become lighter and goes to the top, right? So here we can write down our observation that at 4 degrees centigrade, the lower cyclic current stops and upper cyclic current begins, right? So 4 to 2 degree, rather than contracting, the water will show some abnormal behavior. It will expand, become lighter and go to the top. Eventually the water which was at 9 degree on the top will come to the lower region, eventually attain 2 degrees centigrade. So here we can note that after 15 seconds, right, if we take it for the next 5 seconds, that is for 20, after 20 seconds, the lower thermometer, it is continuing to show 4 degrees centigrade, whereas the upper thermometer, its temperature has gone down to 2 degrees centigrade. Further, so now we have water in the central region at 2 degree. On the top we have water at the 2 degree. The lower water is at 4 degrees centigrade. Because of the freezing mixture, the water in the central region will become 0 degrees centigrade. Again an abnormal behavior. The expansion of the water will take place. It will become lighter, goes to the top. The top water, which was at 2 degree, comes to the central region, eventually cools up and attains 0 degrees centigrade, right? So after next 5 seconds, let's say after 20 seconds, again after 25 seconds, you can note, after 25 seconds you can note that the lower thermometer, it's still showing 4 degrees centigrade, but the upper thermometer, it has shown 0 degrees centigrade. So what happens after 25 seconds, right? We have lower water at 4 degree, the middle water at 0 degree and the upper water at 0 degree. The abnormal behavior is over. Now due to further cooling, let's say this water eventually gets cooled up and slowly it moves to the top, and then the ice is formed on the top layer, and then this layer of ice will slowly expand towards the downward level. Even after, let's say, 150 seconds or 200 seconds, if you note, the ice will be seen till here and the lower thermometer will still show you 4 degrees centigrade, or you may say 3 degrees centigrade. So here some abnormal behavior is seen, that even though there is ice on the top, the lower water continues to be at the higher temperatures. So these were the observations of the Hope's experiment. So what are the outcomes of Hope's experiment? We can clearly establish that at 4 degrees centigrade the water has maximum density, and that is the reason why at 4 degree the water remained there as it is, right? At 4 degree the water remained as it is. That means the density is maximum, and from the relation we know that when the density is maximum, volume will be minimum. So these two facts are clearly established from the experiment, that at 4 degrees centigrade the water has maximum density, and at 4 degrees centigrade the water has minimum volume. When heated from 0 to 4, water contracts rather than expanding. This is another abnormal behavior. And when cooled from 4 to 0, right, water expands. This also we clearly got from the experiment, that when it was cooled from 4 to 0, right, when it was cooled from 4 to 0 degrees centigrade, from 4 to 0 degrees centigrade, right, rather than becoming lighter, right, rather than becoming heavier and settling down, it became lighter. When it was cooled from 4 to 0 degrees centigrade, cooling from 4 to 0 degrees centigrade, rather than becoming heavier, it got lighter and went to the top. So this observation is also clearly seen in the Hope's experiment, that when cooled from 4 to 0, water expands rather than contracting. Ice is lighter than water. Ice floats on the water. Again, we saw in the experiment that ice floats on the top of the water, and freezing of the water starts from top to the bottom. So all these abnormal behavior were clearly proven by Hope's experiment.